Hello, everyone, and welcome back to The Doctor Is In. I'm your host, Dr. Nadia Saba. Today, we are going to continue our series about HVAC for different environments, specifically controlled environment agriculture. And I want to talk specifically today about why HVAC is important for indoor farming, whether you're on a vertical farm, a greenhouse, or a container, or any other controlled environment ag facility. HVAC has a lot of importance in order to grow happy, healthy plants. In our previous episode, I defined HVAC, which is an acronym for heating, ventilation, and air conditioning. We can add a whole bunch of other air conditioning processes to that acronym, including refrigeration, dehumidification, humidification, air distribution, filtration, and many others to come up with, if we wanted, an alphabet soup of HVAC, RD, HAD, etc., etc. But rather than, having that alphabet soup of an acronym, we simply define it as HVAC, which is the engineering industry accepted term. Ultimately, HVAC includes all processes related to conditioning, delivering, and cleaning the air. As I described in the previous episode, originally HVAC was developed for an industrial process, specifically for the printing press. Willis Carrier was challenged with the concern that a printing press in New York had about ink that was bleeding that was caused by high humidity. So the first purpose for HVAC was that D in HVAC, dehumidification. It then found success in other industrial processes, including food storage, and then moved on to the health and comfort of humans, preservation of history and art in museums and tombs and all sorts of other archaeological and artifacts, and has come to apply to many different industries and purposes with the specific goal, again, of creating an aerial environment that protects, preserves, and creates a comfortable setting for people and things. So, when we talk about controlled environment agriculture, the purpose is not really so different than those other applications, right? We are pursuing the creation of an optimal environment to grow plants to their maximum potential when outdoor conditions are not conducive or are potentially hazardous to plant productivity, health, and development. In its most basic form, HVAC and climate management is used to simulate outdoor conditions a specific plant has evolved to grow in, right? We think of tropical plants, and there are certainly, large glass structures throughout the world to showcase tropical plants in locations, usually in cold climates where they don't normally grow, and they have a warm, humid aerial environment. If we start looking at horticulture, right, tomatoes and peppers, they like it hot and sunny, right? Like you find them naturally growing in the southern part of America and the Southwest and Mexico and anywhere where really it's hot and sunny. And so, it was a natural progression for tomatoes to be grown in greenhouses, and we call those hothouse tomatoes, right? Because we are simulating that hot environment that they like to grow in. If we move on to lettuce, lettuce is a little bit finicky. They like cool nights and warm days, and they don't need a lot of light. So we see them often grown in greenhouses in northern latitudes where they don't get a lot of light, but they can, have cool evenings, right, without a lot of heating, and then maybe bright sunny days where it warms up the greenhouse through that greenhouse effect during the day. So lettuce, right, likes we're simulating an environment that lettuce likes to grow in naturally. We find in, say, the Salinas Valley here in California, where you have that fog rolling in at night, and then it burns off during the day and it's nice and warm and sunny. In its most advanced form, HVAC can be used not only to simulate the natural environment that the plant grows in, but enhance it to maximize yield, quality, and the rate of growth of that plant. There have been decades of plant science, horticultural research, and breeding to discover the optimal ranges and targets of various environmental parameters for a multitude of horticultural and commodity crops. I say that, but I do realize, right, and acknowledge that cannabis is sort of the outlier to that comment. And we have so much science and research to do on that particular plant. So there are several environmental parameters that we know of that affect plant growth and development and health. Number one that most people think of is light, right? The intensity, the duration, the timing, whether or not a plant is a short day or a long day plant, all affects how the plant is going to grow and its rate of photosynthesis. Well, in order to photosynthesize, the plant also needs carbon dioxide. Plants are autotrophs, which means that they don't go out hunting and foraging for food. They produce their own food from their surroundings. And so they use carbon dioxide in the photosynthetic process to break it down along with a water molecule to produce carbohydrates, both to energize it as well as to build it up, right? Because plants are essentially carbohydrates. And that light is what activates the photosynthetic process. Plants also, of course, need nutrients for their health and development, to build strong immune systems, and to have, the right quality and aesthetic to grow well. Plants also need water, of course, and they use water to move nutrients from the roots through the plant and to other parts of that plant. And in fact, in non-woody crops like our horticultural crops, that water actually creates a turgor pressure within the plant that helps it to hold it upright. And that process of moving water from the roots and through the plant is called transpiration. Other parameters, of course, include which is related to HVAC, is temperature, which supports plant functions and the rate of growth and the rate of photosynthesis, and vapor pressure deficit. The VPD is what affects the rate of transpiration. It affects nutrient delivery as well as how much water the plant is going to use. Not a single one of these parameters works alone or in a vacuum. A plant that's irradiated with lots of light but lacking carbon dioxide will grow slowly or potentially not at all. In fact, we've had a few clients here at Dr. Greenhouse where they had all the parameters, perfectly optimized, but because they had sealed up their farm, had no ventilation, and didn't think to enrich their rooms, their grow rooms, with carbon dioxide, the plants didn't grow at all. And once we determined that the CO2 level was less than 200 parts per million, that was something that we fixed right away. Also, a plant with lots of light and carbon dioxide that doesn't have access to water at the roots will close its stomata to protect itself, will wilt, and will eventually die if you never feed it any water. Of course, the opposite can be true. A plant can become waterlogged if you water it too much, causing root rot and other issues where the plant also can't uptake water. A plant that's grown under a high vapor pressure deficit where the air is really, really dry will take up water really quickly from the roots, but may leave calcium behind, resulting in leaf tip burn or blossom end rot in, say, tomatoes and peppers. So, getting the right combination of temperature and humidity is really important in order to manage the process of transpiration and nutrient delivery to the other parts of the plant so that it grows healthily. You know, Alternatively, right, if all these plants are in balance with each other, right, not out of balance, which I just described a few scenarios of that, if they're in balance and co optimized, the plant not only will grow, it will thrive, right? And so that is the most advanced form of HVAC, is not only to simulate the natural environment and give the plant, what it basically needs, but to find the point at which all of these parameters work together so the plant is optimized for its best self, right? Whatever that best self is. Usually we determine that as a grower, right? Is the best self a really quick growing plant? Is the best self a really high yielding plant? Is the best result a really high quality plant, but maybe low yields, right? I think ideally every grower would prefer for all of those to come together. Usually they don't. Usually you don't get all three at the same time, but we do know that we can co optimize these variables to at least achieve two of these together. So, going back to HVAC, right? In controlled environment agriculture, HVAC systems are used to condition the air, right? Using cooling, heating systems, dehumidification, humidification, right? These systems that are managing temperature, that's the cooling and heating, and managing the humidity, which is dehumidification and humidification, to achieve that sweet spot of vapor pressure deficit. And by doing so, the HVAC system ultimately affects all of these processes I just described before. It affects the photosynthetic rate, it affects the transpiration rate, nutrient delivery, as well as deficiencies, water use and the efficiency of that water use, and leaf temperature. HVAC is also used to deliver and move air around the plants using air distribution, right? So using ducts, using fans. Maybe you're in a greenhouse and you can open up the vents, and now you rely on the wind to help move air in and around the plants. And air distribution, why is that important? It's, well, for a couple reasons. One is that it's responsible for delivering carbon dioxide to plants in order for them to photosynthesize. And at the same time, that air movement removes oxygen, which is the waste product of photosynthesis, right? To a place where maybe we want to oxygenate and the air. Air distribution and air movement is also important for removing water vapor, right? Which is the byproduct of transpiration, so that we don't form this microclimate of a very humid air around the plant, which could stifle its growth and transpiration. HVAC in controlled environment agriculture is used to clean the air surrounding plants using screens, particle filters, scrubbers, and other devices that remove potentially hazardous constituents, right? And these could include insects and birds, right? In its most simple form, again, if we're using screens, mold spores with particle filters, pollen and dust with particle filters, and in some cases, we might have very specialized filtration systems that remove viruses, ethylene, and other potential airborne contaminants. If you are using the off gas from a combustion system to deliver CO2 to your greenhouse, for example, you might want to scrub that air first to ensure that there's no ethylene in it, that there's no NOx or SOx that could not only damage your plant, but also be harmful to the people working in that greenhouse. When the aerial environment is in balance with other growth parameters such as light, carbon dioxide, water, and nutrients, the plants will thrive. When the growth parameters are out of balance, plants can become stressed, right? Which is exhibited by wilting, nutrient deficiencies, greater susceptibility to disease, slow or no growth, and even switching from vegetative to reproductive growth. That, in some cases, exactly what growers want, right? Where we steer the plant to go from the vegetative stage into a generative stage where the plant produces flowers or fruit. We can save that discussion for another episode. But in a nutshell, HVAC systems are used in controlled environment agriculture to manage and control plant comfort and stress, which has a direct impact on the plant growth, development, and its health. Thanks everyone for listening to this episode of The Doctor Is In. I'm your host, Dr. Nadia Saba, and I wish you all an amazing day of happy, healthy, and thriving plants.